Listeners, today is June 4, 2025. Accurately measuring fuel consumption is not just a regulatory requirement. It is a vital issue. It's a vital part of the product development, customer satisfaction, and environmental responsibility. Our topic of discussion today is fuel consumption test procedure, especially tailor-made for motorcycles, scooters, and auto rickshaws. Hope you have already watched our video on the subject of prerequisites, preparation, and protocol for the standard testing procedures for complete motorcycles and scooters. Here is the procedure to conduct fuel consumption test. Number 1. A proper test course should be prepared for all the tests, including fuel consumption test. Number 2. Mark 2 points on the test tracks at a distance of x1 and x2 from the origin. Fuel consumption is to be measured for this particular stretch, that is from x1 to x2, and designated as S meters. The point x1 from the point of origin is at a distance of 300 meters. The point x2 is at a distance of 500 meters from the original points, that is the point of origin, and the total distance from the point x1 to point x2 S is 200 meters. Number 3. Burette and the feeding fuel pipe to indicate fuel level on the burette, and the three-way cock or solenoid valve shall be installed on the motorcycle or scooter in such a way so that they are located on the left side of the rider for easy handling and operation. Number 4. It must be ensured that the fuel pipe is of minimum length, it is not bent, it is free from air bubbles, and it is not prone to overheating due to any routing issues. Number 5. The three-way cock shall be checked for smooth operations and leaks. Number 6. The test shall be conducted at a speed of 20 km per hour with the increase in speed by 10 km per hour intervals. Fuel consumption is to be noted for the distance x2 minus x1, that is 200 meters, and designated as S, as shown in the previous illustration. By the way, what is a three-way cock? It is a manual or semi-automatic valve with three ports or connections or inlets or outlets. It allows the fuel to flow in one of the three configurations depending on as to how it is operated. How the three-way cock works during the test. Three-way cock has three operating positions. That is position number 1. At position number 1, engine runs on normal fuel tank. That is a normal mode. At position number 2, it is a test board position. Engine runs on test burette, that is a measurement mode. We shall be using this position during the test. Position number 3 is fuel cutoff or bypass or a turn depending upon the design of the testing fixtures. And this is a situation when the tests are conducted, that is, simulated under the controlled conditions. The rider switches the three-way cock to its position number 2 to measure how much fuel is consumed over a known distance, in this case 200 meters. After the test, he will switch on to its original position, that is position number 1. How the rate of fuel consumption will be calculated. In our case, the total distance covered is S, that is the distance covered between x2 and x1, that is 200 meter. Suppose the total fuel consumed is 2 cc, then the rate of fuel consumption F is equal to S divided by Q, that is 0.2 kilometer divided by 0.002 liter, that is 100 kilometers per hour. In case of mixed fuel, the rate of fuel consumption will be calculated by this formula, that is, F is equal to S divided by Q multiplied by the correction factor M plus 1 divided by M, whereas F is equal to rate of fuel consumption, S is the distance traveled, Q is the total fuel consumed, M is the mixing ratio. What it means? This formula adjusts the basic fuel consumption rate to account for fuel mixtures, like in two-stroke engines, where oil is mixed with fuel. The basic fuel consumption without this adjustment is S divided by Q, as discussed before. The factor M plus 1 divided by M, that is called a correction factor, corrects the result to account for the presence of oil in the fuel mixture. Since not all the volume in the tank is fuel, some is oil. The mixed fuel case example is, suppose distance traveled S is equal to 100 kilometers, fuel consumed by volume Q is 5 liters, oil to fuel mixing ratio is 25 to 1, that is fuel to oil. Therefore, the value of M is 25. The rate of fuel consumption will be S divided by Q multiplied by correction factor M plus 1 divided by M, that is 100 by 5 into 25 plus 1 divided by 25, that is 20 into 26 by 25 is equal to 20 into 1.04, that is 20.8 kilometer per liter. This is adjusted fuel consumption rate of 20.8 kilometer per liter, considering the oil content in the mixture. Analogy. Suppose this case is like, suppose you mix 1 liter of orange juice with 0.1 liter, that is 100 cc of water. You drink 1.1 liter of total liquid. If you are counting juice content, you only drank 1 liter. If someone says you drank more, that is only true by volume, not by actual juice content. Same is here with the fuel. With mixing, you burn more liquid volume, but only part of it is fuel. The oil is extra weight, not an extra energy. Thanks for watching. Stay tuned for our next topic on the subject of maximum speed test. Until then, goodbye and see you soon. If you like the content, please don't forget to push the button, like, subscribe, and share. Thank you. Thank you very much.